This is Wilfried, the PCB designer, again. Based on the component placement, I want to pre-optimize the FPGA pin assignment to reduce the breakout and fanout effort. These steps helps us to identify channels much easier and allows us to make good design decisions about routing layers and sorting of signals. Netline filtering helps me to define a strategy upfront, and I can set the focus on critical nets like the DDR4 data and strobe signals. In addition to that, it is easier for me to review changes in the pin assignments later. FPGA I/O optimization is tightly integrated into the Xpedition layout flow. It keeps schematic, layout and the vendor FPGA project in sync by using a synchronization assistant. This assistant has direct access to the central database and to vendor constraints and HDL files. I/O optimization is accessible at any stage of the project using the Xpedition schematic environment. The I/O optimizer is directly associated to the FPGA symbols. This saves a lot of time searching for commands in menu and toolbars. The main advantages of the integrated I/O optimization are that it knows all the FPGA vendor rules for pin assignment and swapping, and that it is PCB aware. The floor plan view represents the current state of the PCB layout and allows the user to filter for nets and layers. On top of these, the placement can be adjusted here, and the changes are sent back to Xpedition PCB. The process of swapping multiple netlines to avoid crossing is called unraveling and can be controlled based on the current layout state. In this early design stage, we have few restrictions and do not need to take care of the layer usage. With these optimized pin assignments, it will be much easier for SAG to do the fanout and breakout. This means that the number of wires and layers can be reduced, which improves the signal integrity and reduces the board fabrication cost. Finally, all data is transferred to Xpedition layout, and the net filtering allows us to identify all changes very quickly.